Intermeshing Rotor Helicopter, Synchropter. An intermeshing rotor helicopter, also known as a synchropter, is a unique type of helicopter characterized by two main rotors, turning in opposite directions. These rotors are mounted on separate masts, each angled slightly towards the other, allowing their blades to intermesh without colliding. This configuration offers several distinct advantages and disadvantages compared to other helicopter designs. How it works. Counter-rotation. The two main rotors rotate in opposite directions. This counter-rotation naturally cancels out the torque that would normally be generated by a single main rotor, eliminating the need for a tail rotor. Angled masts. The rotor masts are mounted at a specific angle, e.g., 25 degrees in the Kaman K-MAX, and are synchronized by gears. This precise angling and synchronization ensure that the blades of one rotor pass between the blades of the other without collision. Yaw control, yaw, turning the helicopter left or right, is achieved by varying the torque on one of the rotor sets. This is typically done by increasing or decreasing the collective pitch on one set of blades, creating a differential thrust that causes the helicopter to pivot. Lift and thrust. Both rotors contribute to lift and thrust. While neither rotor lifts directly vertically due to the mast angle, the combined effect provides powerful lift. Advantages. No tail rotor. The most significant advantage is the elimination of the tail rotor. This saves power, as 10–25% of engine power in conventional helicopters is used for the tail rotor, reduces mechanical complexity, weight, and maintenance, and improves safety for ground personnel, as there's no dangerous tail rotor to worry about. High lifting capacity. Intermeshing rotor. Helicopters are known for their powerful lifting capabilities, making them well suited for heavy lift operations, e.g., sky crane, logging, construction. Stability. The design provides good stability during flight, particularly in hover. Compact footprint, relatively. While the height might be greater, the absence of a tail rotor can lead to a more compact ground. Footprint compared to single rotor helicopters with tail booms. Quieter operation. The absence of a tail rotor and the interaction of two main rotor airflows can result in quieter operation compared to some conventional designs. Disadvantages. Reduced efficiency per rotor due to the angled masts. Neither rotor lifts directly vertically, which can slightly reduce the efficiency per individual rotor compared to a perfectly vertical rotor. However, the overall system can still be very efficient for lifting heavy loads. Complexity of synchronization. The precise synchronization of the two rotors to prevent blade collision is a critical and challenging design aspect. Lower forward speed. Intermeshing rotor designs often have limitations on maximum forward speed due to rotor turbulence and aerodynamic interactions. This can make them less suitable for high-speed, multi-role applications. Specialized maintenance and training. The unique design may require specialized maintenance procedures and pilot training. Limited widespread use. Despite their benefits for specific applications, intermeshing rotor helicopters are less common than conventional designs due to production challenges and market demand. Examples. Historically, intermeshing rotor helicopters were pioneered in Germany by Anton Flettner. Notable examples include Flettner Fl 265, 39, pioneering example of the design. The Flettner Fl 282, Colibri, 1941, a small anti-submarine warfare helicopter. Kaman HH-43 Husky, 1953, produced by the American Kaman Aircraft Company for USAF firefighting purposes during the Cold War. Kaman K-MAX, K-1200, 91. Perhaps the most well-known modern example. It is a dedicated sky crane optimized for external cargo load operations, known for its exceptional lifting capacity. It has also been explored for unmanned and optionally piloted variants. The intermeshing rotor design represents an innovative approach to helicopter engineering, offering distinct advantages for specific heavy lift and stable hover applications, even if its overall adoption is more niche than that of conventional single rotor helicopters.